Hey, what's up everybody? We are going to do a quick 10-minute video. We're going to dive right into the 2018 MCAS release questions in mathematics. Let's go in right now. All right, question number 2 that's released. What is 2.03 times 10 to the 11th written in standard form? Standard form? What is standard form? Standard form is just a number that's written as a regular number. It's written in standard scientific notation here, as you can see by the 1 digit to the left of the decimal point. That's between 1 and 9. And of course, the other factor that has a base of 10 raised to the 11th power. All right, what is this written in standard notation? Well, what you need to do here is just write your number, and with the magic of the iPad, we are going to move. Well, this is a really big number since this is a positive 11. I'm just going to add a bunch of zeros here, and you'll see why in a second. All we need to do is count this number 11 and move this decimal point here over 11 spots to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to belong right there. Let's throw some commas in there to separate our periods. And this looks like is B. All right, moving on. Two rectangles and some of their dimensions are shown. The rectangles are similar. What is R, the length in feet of the smaller rectangle? Okay, so that word similar is the key word here. Similar means that the angles are going to be the same. Of course, rectangle, the angles are all 90 degrees, but more importantly, their side lengths are going to be proportional, or they're going to sort of be equivalent ratios to each other. So if we can look at either the relationship between these two sides and compare it to these two sides is one way we can do it. Or we can look at the relationship between these two sides and the big triangle, and it's going to have the same relationship between the two small sides in the smaller triangle. All right, just looking at this, let's just go within the triangle because that's not as obvious, I think. So let's look at the pink arrows here. The ones on the left, the relationship between this big one and the small one is 6 over 1.5. And we can take a look at finding that relationship a couple of ways. One way is just to maybe multiply, get rid of that that decimal in there. Let's multiply each side by 10 to get a fraction. It's an improper fraction, but we've got whole numbers in the numerator and denominator. And here maybe we can just simplify this factor. Look at common factors that they share. Definitely there's going to be a 3. So I'm going to take 3 out of the top and 3 out of the bottom, and I'm going to end up with 20 over 15, right? And it looks like they have a factor of 5 too. So if I divide 5 out of the numerator and denominator, I'm going to get 4/5 or 4/3. So the number that relates them to each other is either 4/3 or 3/4. This is the common ratio they have depending on which sides you're talking about. So let's see if we can stick that in here. I'll draw you some arrows. So it's basically 4.5 times 4/3 is going to get me 6, is basically what we just figured out. Or you can take 6 times 3/4 to get 4.5. But since we're going this way, we're more interested in multiplying the 3 by 4/3. So we're going to take 3 times 4/3. And since this is a whole number, we're going to make that a fraction. We're going to simplify the 3's, reduce the 3's from both of those, simplify that, and then we end up with 4. All right, so our answer here is 4 feet. Now, the problem with this one is, and I know there's a lot of decimal people out there, if you try to do this with a decimal, you're going to end up with a repeating decimal. You're going to get 1.3 repeating. And that's going to be tough if you put that in a calculator, or if you just try to do that out. 1.3 repeating is going to get you a number that's going to be really close to 4. I don't think it's exactly going to be 4 though. So they are looking for 4. You need to use the fraction in this problem to figure that out. All right, moving on to number 6. Lucinda determined that the diagonal of her laptop screen is 2 times the square root of 42 inches long. What is the approximate length to the nearest inch of the diagonal of her laptop screen? Oh boy, this is going to take a minute. So now when we're talking about the diagonal, we're looking from edge to edge here. This is 2 to the square root of 42. Now that 2 in the beginning is just like, that's just a number that you're going to multiply square root of 42 by. So square root of 42 is going to be a number in between the perfect squares of 6 and 7, 49. And so if you look here, it is it's 8 away from 36, and it's also, what is this, 7 away. So it's almost right there in the middle. So I think a good decimal approximation that we're going to use is right there in the middle at 6.5. So what you need to do is just take 6.5, multiply it by 6.5, because 6.5 squared hopefully is going to get us a number that's really close to 42. So we end up with 25. This is 32. 6 times 5 is 30. 6 and 6 is 36 plus 3 is 39. Add these all up. Move that decimal place over 2 decimal places here to get a number that's pretty close to 42. To the nearest inch. Okay, so we're going to take that 42, we're going to take that 6.5. So we could test it out and do 6.4 and see if we get closer. And, well, let's just see if we get a number that's closer to 42. I don't think we will, but let's try it. This is 16, 25, this is 24, 36, 38. So we got a number that was not as close. So what we're going to do is just take the 6.5 and multiply that by 2, since it's pretty close to the number that we want. And this is going to be 13. All right, so I would say to the nearest inch, this is going to be 13 inches long. Now, you want to be careful here, because according to this, if you take your decimal, if you just go for an inch approximation and you pick 7, this 7 here, and you just do 7 times 2, then you're going to end up with 14, which is going to be a little high. And obviously, if you did the 6, you would get 12. And I think we're looking for a number that's right there in the middle of 13. So be careful here. We are looking for 13 inches. Which of the following is an irrational number? Square root of 0. 0 times 0 is 0. So this one is rational. This one is a repeating decimal, which is also rational. This one is a negative decimal. This is rational. This is the only one that is irrational. And it's irrational because there is no number that you can multiply by itself to get to 3. You can multiply, to find the square root of 4, it's 2 times 2. The square root of 1, it's 1 times 1. And I guess square root of 0 is 0 times 0. But there's no number that you can multiply by itself to get to 3, which is what makes it irrational. Which of the following equations represents a linear function? All right, so linear functions here, we want to be thinking about those linear equations where it was like in the form ax plus by equals c, or y equals mx plus b, or any of those other equations that you might have heard about, setting slopes equal to each other, etc. So these right here, these exponents ruin everything in this problem. So that is not a linear equation. This exponent here, not a linear equation. So I guess it's between these two here formed. We can write this as y equals 1/12 x, right? And we can also rewrite this one as y equals, well, if what's x times x is x squared plus x times 3 is 3x. So even though this one looks like it would be a linear equation because there's no exponent right when you first look at it, if you multiply it out, get rid of the parentheses, use the distributive property, you'll see that there is a square up there. All right, next one. This table represents a linear relationship between x and y. That is good. Based on the linear relationship of this table, what is the value of y when x is equal to 4? All right, I guess we can just continue this table. Hopefully we can see a pattern that's created here. You know, instead of just writing an equation, we just want to find this number efficiently. So you can see that x is increasing by 2 each time. This will be 2, this will be 4. So when x is 4, we're interested in this column right here. What happens on the other side? Well, here we're just subtracting, no, we're adding 1 each time. So we add 1 here to get 1, add 1 again to get 2. It looks like y is 2. All right, moving on. This question has 4 parts. A student wrote the equation shown x to the y power equals z. What is the value of z in the equation when x equals 3 and y equals 4? Sure, explain how you got your answer. Well, this is just a matter of substitution, all right? So what you need to do is just rewrite this problem. If x is 3, so here we have x raised to the y power equals z. So if x is equal to 3, you're just going to put 3 where x is. And if y is equal to 4, you're going to just put 4 where the y is. And then that's going to equal z. So all you have to do here is evaluate 3 to the 4th power, which is going to be 3 times 3 times 3 times 3, which is 9 times 9, which is going to get you 81. Z equals 81. What is the value of x in the equation when y equals 3 and z equals 125? All right, so we're going to just do the same thing. Just rewrite it. You don't know what x is, but it's raised to the 3rd power, and that's going to be 125. So what number raised to the 3rd power? What number multiplied by itself? If you write itself 3 times, is going to equal 125. So basically, x times x times x equals 125. What number is that? Let's just look at our perfect cubes. All right, let's go back to that. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 80, no it's not, it's 64, 5 cubed is 125. I think we have our number here, 5 cubed. Now you can also do this using, x is going to be equal to, just take the cube root of each number, x is going to equal to 5. You could do this using primes. You could do this using prime factorization. So by using prime factorization to answer this question, you could just take 125 and then just take out the prime. So you see it ends in a 5. You know a 5 is going to be one of the numbers. So 5 times 25 will get you 125. This is prime, 25 is not prime, and then you just take your 5 times the 5. And if you can see that there's 3 5s there, that tells you 5 times 5 times 5 is 125. And so 5 cubed is 125. All right, the student rewrote the equation as shown. Is the value of x a rational number when y is 2 and z is 2? Explain your reasoning. Well, let's look at what this looks like. And again, we're just going to do some substituting. 2 and 2 is equal to x. This basically says the square root of 2 is equal to x. And there is no number that we multiply by itself to get to 2. No, it is not rational because there is no number that you can multiply by itself to get 2. All right, that's all you need. Write an integer value of y and an integer value of z that makes the equation true when x equals 8. So we want to figure out this and this. Okay, not too bad. So we'll just have to figure out the square root of something is 8 or the cube root of something is 8. You could do maybe the square root of 64 is going to be 8 because 8 times 8 is going to be 64. And if you want to change this around, you can just say, okay, 6 equals, what number equals 8 to the something power equals some number. So you can really do anything here. You could have made this to the 3rd power, and that's 8 times 8 times 8, which is 64 times 8, which is going to get you 51. Okay. So a couple situations, a couple things that you could have wrote here were y is equal to 2 and z is equal to 64 for this first one. And then for this next one, y is equal to 3 if you took the cube root of 512. You could use either one. All right, moving on. Which pair of steps can be used to completely solve this equation? We have 4x minus 5 equals 17. Yeah, you want to do the addition or the subtraction first. It's kind of like opposite of PEMDAS here, so this is the first thing you want to do. You do want to add 5 to both sides and then divide both sides by 4. And if we actually did that, right, it looks something like this. You want to end up with 4x equals 22, and then divide each side by 4. X is going to be 11 halves or 22 fourths, right? So I would go ahead and stop right at this first one. You don't want to divide both sides by 4. If you did that, I mean, you could do it, but the next step, adding both sides, adding 5 to both sides, doesn't really make sense. Since you wouldn't have 5, you would add 5 fourths to each side. You could subtract 5 from both sides, but that doesn't really help you isolate the variable at all. It's going to give you negative 10 or minus 10 on the left side. And then finally multiply both sides by 4 and then subtract by 5. Don't, I mean, you could do that. You could do that, but you wouldn't subtract 5 from both sides. All right. Number 17, change the which of the following represents the linear relationship with the greatest rate of change? So when you have a linear relationship, when you have it, so A is written in slope-intercept form. So when it's written in that way, 2 represents the rate of change, the relationship between the change of y and the change of x, or the slope. So the slope here is 2, represents that rate of change. The rate of change here looks like for every x, it goes up by 1. For every y, it goes up by 5. So the rate is going to be y over x, which is 5 over 1, which in this case is going to be 5. A line rises, the rise, change of y, for every 3 units it moves to the right over the change of x. So we have 9 over 3, which is going to get us our change of 3. And finally here, rise over run, I see a point right here, and I see a point right here. This goes up 4 and over 1. So out of all of these, the greatest rate of change here is going to be 5. All right, this next one. This diagram shows a cylinder that has a radius of 3 inches and a height of 5 inches. What is the volume of cubic inches of the cylinder? So the volume is going to be the base times the height. And in this case, our base is a circle. So that to find the area of the base, we use the area formula for the circle, which is pi radius squared times the height. And let's substitute in some values. And keep in mind that we don't have to multiply by pi because, as you can see, the answers are all given in terms of pi here. So we don't have to multiply by pi. We just keep pi in our equation. So our radius is 3. We're going to square that times the height of 5. Now just be careful here that we need to square the 3 first and then multiply it by 5. We can't take the 3 and the 5 and then square that. So we have pi, 3 squared is 9 times 5, and then v equals pi times 45. I got that by the 9 times 5, and then, you can just switch the order of everything to make it look like C. Which of the following is equivalent to this expression? And you just have to know your integer rules here, which when you're multiplying integers with the same base, you can just add their exponents. So we have 7 to the 2 plus -4, which is 7 to the -2 power. But as you can see, this is none of our equations, so we have to take one more step here. When you have a negative exponent, you can get rid of that negative by pretty much turning the base, just switching the order or taking the reciprocal of the whole number. So if you have 7 over -2 over 1, to get rid of that negative, it's just 1 over 7 squared, which looks like B. All right, guys, thanks for sticking with me. That is the 2018 MCAS released questions for session 1. And if you have any questions, just leave them in the comment section down below. Please subscribe and tune in for more study tips. Thank you very much. We'll see you next time on Math Toast.